Hello guys, you are welcome to Chris Control Automation. In this video, we are going to learn how to configure the variable frequency drive and use it to control an induction motor. So let's get started. We are going to configure this particular drive. It is a single phase input to three-phase output drive. Before we will be able to configure this drive, we have to look at the manual. Every drive has its own manual. There are some default configurations and settings on most of the drives. So I have selected the most basic settings and configurations for every drive that we find out there. This particular drive came with this manual, but they indicated three-phase input. What it means is that there are other models that has the three-phase input, but they are all the same brands. These are the control terminals, X1, X2, X3, S4, and then this is the ground. We have the relay output contacts. These are the analog input contacts or terminals. This is the communication terminal. Let's look at this one. We have RST and ground, three-phase input. The PB is the breaking resistor terminal. We have the output UVW and then ground. On this block, we have the terminals here, TC and TA. They are the relay output terminals. X1, X2, X3, S4. They are the control terminals. A plus, A minus are the communication terminal. AI2, analog input terminal 2. This is where we control the drive speed using potentiometer, external potentiometer. This is 10 volt and then ground. The drive produces 10 volt DC output. When we power it on the drive, we get 10 volt DC from this terminal. This is current and voltage selector knob. In case you are using a potentiometer or any analog means to control the speed of the drive, you either select current or voltage, depending on what you are using to control the speed of the drive. Either it gives current or voltage output. And then these are the explanations of the terminals. Analog input terminal AI2, switch input terminal X1, X2, X3, S4, relay output terminal TATC, auxiliary power terminal, that is the 10 volt DC and then ground, RS485 communication terminal, A plus and then A minus. In case you want to control the drive using Modbus communication method, this is where you connect the cables. On the drive, we have the input, live and neutral. They've covered these terminals. And then these are the output terminals, U, V, W, and then ground, three-phase output. And these are the terminals I showed you on the manual. This is the current and voltage selector knob. It is inside unless you insert the screwdriver. As I mentioned earlier, I have selected the basic configurations of most drives in the industry. And we are going to control an induction motor using the drive. A. Command source selection. That is P0.02. Every drive has its own function code table. And this is the function code table for this drive we are using. So we have function code, parameter name, setting range, default, and property. This is P0 column. P0.01. The parameter name is Motor 1 control mode. The default setting is 0. So 0 is voltage or frequency control. When you come to P0.02, we have command source selection. And default selected value is 0. It means operation panel control. What it means is that in case we want to control an induction motor using the drive, we are going to use the buttons on the drive itself. So this is a potentiometer. This is where we increase the speed or frequency of the drive. This is the run button, stop or reset button, and these are the programming buttons. In today's video, we are only going to learn how to control an induction motor using the buttons and then the potentiometer on the drive. So we are going to select operation panel control. They are saying the default number selected is 0. So we are also going to confirm whether it is 0. We have to power on the drive before we'll be able to do the configurations. I'm going to connect live and neutral to the input. I am turning on the power. Number A says command source selection. So we have to select P0.02. P0.02 command source selection. So we go to the drive. This is the programming button. You press on the program button. You have P0. You press enter. Now we have P0.00. You press the top arrow button to increase it. P0.02. So we press enter. We are seeing 1. 1 is terminal control. What it means is that I use external push buttons to control the drive. So I selected 1. Now that we are come to use the operation panel buttons, we have to select 0. Operation panel control 0. So you press the down arrow. You press enter. We are done. We go to the next option, main frequency selection, P0.03. P0.03 main frequency selection. The default value is 0. They use this one, but we are going to use this potentiometer to increase or decrease the speed. So you select panel potentiometer, that is 2. So press enter. You select 2. Then we go to rotation direction, P0.09. We are going to select whether the motor should run in forward or reverse. So P0.09. Press enter. P0.09 rotation direction. 0 means same direction, 1 means reverse direction, and they have selected 0, that is same direction, meaning forward direction, and 0 is already showing, meaning it is in forward mode. You press enter. Now we come to maximum frequency. It is P0.10. But before we select P0.10, let's select P0.08 first. P0.08 is preset frequency. It means minimum frequency to maximum frequency. And they selected 50 Hz. So let's confirm. P0.08. We come down. We press enter. We are seeing 50 Hz. Then we come to P0.10. Press enter. P0.10. Enter. We are also seeing 50 Hz. Let's confirm. Maximum frequency. We have 50 Hz to 600 Hz. They selected 50 Hz. That is why we are seeing 50 Hz here. We come to the next option. E. Acceleration or ramp up time. P0.17. P0.17. Acceleration time. 0.00 seconds to 65,000 seconds. This is the time given to the drive, so that when you press on the run button, it will increase from 0 to the maximum speed within that time frame. So we select P0.17. We have 20 seconds. So it means that when I press on the run button, the drive would start from slow speed and then it will increase up to 8 maximum speed within 20 seconds. You press enter. The next option is deceleration or ramp down time. P0.18. Deceleration time is 0.00 seconds to 65,000 seconds. So let's press enter. We have 10. It means that when you press on the stop button, the drive should decrease its speed from the maximum to the lowest speed, that is 0, within 10 seconds. So I have already selected 10 seconds. We are moving to another important option, motor parameters or parameterization. This is where we input the nameplate data of the motor onto the drive. So we have motor type. What type of motor are you using? P1.00 motor parameters. P1.00, that is motor type selection. They have selected default number 0. So the 0 is common asynchronous motor. Asynchronous means induction motor. It is not a synchronous motor. It is P1.00. We press on the left arrow and then the top arrow. P1.00. We press enter. They have selected 0, meaning asynchronous motor. We press enter. We have motor power, the kilowatts rating of the motor. So that is P1.01. P1.01. We press enter. We are seeing 0.4. My motor is 0.4 kilowatts. So I've already entered 0.4 here, as you see. We press enter. Now we have motor voltage P1.02. We press enter. P1.02. My motor runs on 380 volts. So I selected 380 volts. Press enter. Motor current P1.03. So we press enter. The current rating of this motor is 1.27. We press enter. Motor frequency P1.04. We press enter. 50 Hz. And then motor speed P1.05. We press enter. The motor speed is 920 RPM. Okay, there are other parameters, but these are the basic ones you have to do. Now we are coming to operate the motor. So let's press on the program to go back. You can see we are having 0.00. When I turn the potentiometer, it will increase. It is increasing up to 50 Hz. That is the maximum frequency you have given to the drive. So let me bring it back to 0. Now we are coming to connect the output to the motor. This is our 3-phase motor. We have the line 1, line 2, line 3. So the red is line 1, line 2, and then line 3. So before we do that, I will turn off the drive first for safety reasons. Now that the drive is off, we can connect our output. And this is the ground, but I am not connecting the ground now. But when you are doing at your place, make sure you connect the ground. This is just for demonstration purpose. So now our drive is on. Our input and then output. We are coming to run the drive. So we will press on the run button. When I turn the potentiometer, the shaft will start to rotate. I am turning it. So I am increasing it small. Look at the value. 4 Hz, 5 Hz, 6 Hz, 7 Hz. So as you are increasing it, and then it is also increasing. Hz. I'm going. Now, this is the maximum speed, 50 Hz of the drive. See something again. We have deceleration or ramp down time. It was 10 seconds. So when I press on the stop button, it will take 10 seconds to stop. You see that? So this is the deceleration time. When I press on the run button, it will take 20 seconds. See. You see that? The starting is a bit longer than the stopping. When I press on the stop button, see that? The stopping is a bit shorter than the starting, you see? Now I am going to decrease the deceleration time or ramp down time from 10 seconds to to, let's say,